Hey everybody, and welcome to the Daily Space Weather. Today we're talking about Hurricane Laura making landfall as Category 4, Cygnus X-2, more stuff about Oumuamua, and climate. I'm your host Dan. Thanks for tuning in, by the way. Here is a 48-hour SDO video of the local yellow dwarf, otherwise known as the Sun, or if you prefer, Sol. Coronal holes up by the North Pole. No sunspots today. Fairly weak activity, and I think we actually saw a glancing blow coronal mass ejection strike. We'll get to it in a minute. First, let's take a look at the fields, as the magnetism is what makes this object behave as it does, apparently. And again, no sunspots currently visible. There is a little bit of magnetic organization going on down in this area. But again, no sunspots. Here's the 304 angstroms view. We have some filaments up there in the northeast associated with that active region. So let's take a look at those. Here's the 304 angstroms view of that. And I'll let that play through once or twice. And that filament up there in the north is pretty stable looking, actually. Not a lot of activity going on with it at this point. We've also got the 171 angstroms view of this area, a little bit zoomed out. And here's that custom helioviewer.org movie. And you can see the differences in that structure in terms of ionized iron, which is the 171 angstroms UV emission spectra, versus the 304. Great view of that active region. And let's get to a whole lot more data, as there's plenty of stuff to cover today. 10.7 centimeter radial flux is still at 70 solar flux units, and there is the graph of sunspot number as well as 10.7 centimeter radial flux. By the way, that's on the Space Weather Enthusiast dashboard if you want to look that up yourself. Don't take my word for it. KP index made it up to 3 there for a brief period, now back down to 2. We don't see any X-ray flares, no solar flares, and we don't see any significant proton events. Now here's what I was talking about a possible glancing blow coronal mass ejection strike. You can see right here the temperature, the wind speed and density, the phi angle, and the BT/BZ all shift at the same time, and that looks like a small coronal mass ejection strike there following the subsiding of this coronal hole wind stream. So you can see the wind stream comes down and then jumps right back up at the same time as the solar wind density does. Current conditions are 4 protons per cubic centimeter for the solar wind density and 406 kilometers per second, as we've seen a ramp down following that about 9 hours of a slightly increased density and speed. Next, looking at geospace magnetosphere movies. And when I look at these backwards during show prep, by the way, it does give me an indication of what the solar wind data will read. Although occasionally pure magnetism affects it, usually the solar wind data and the geospace magnetosphere movies correlate very nicely. Anyway, there's 4 hours of data. Fairly weak magnetosphere. Now moving a little closer to home to look at ground magnetic perturbations. And welcome to the geomagnetic excursion. Let's move that back to where it was before it refreshed to show you 4 hours of data on that. And if you don't know about the polar excursion, maybe we'll have to do a video about it. I'm not sure if that should be a cosmology segment or not. Next, looking at the GOES magnetometer, and you can see these continued spiky areas here and not a very smooth graph over the past 3 days. No surprise there, as I've been forecasting it. Why? because of this data here. It's the line of sight, it's the top view ecliptic plane field plot. We see some indications of the south solar polar field charging up the current sheet, which you'll see in red. Most of it's still in green, north pole polarity. So you can see these structures here in the corona, and that's what's causing those striations in the GOES magnetometer, as there is a big variation in the potential field force lines due to some plasma in between you and the sun. This data gathered from 51 ground-based magnetometers, as well as magnetometers on stereo A and stereo B. And here's the line of sight field plot, and you can see the way the B field here, shown in blue, is affected by that active region. Pulling that around a little bit. And that area of activity is indeed, I believe, why the South Pole current sheet is showing up in our local vicinity out towards stereo A. Lagrange point 5. I think it's actually Lagrange point 4, but anyway, yeah, stereo A. And here's a synoptic map, and you can see some plasma filaments, mixed fields, again, no sunspots. And let's move on to a cosmology segment, as there are some more interesting stories, once again, about things like Cygnus X-2 and Oumuamua, not to be confused with Jason Momoa. So let's talk about our mission. You can read all about it at smashomash.com/forum/mission. Number 6 is to assist mankind, the humans, as the Ferengi would put it, to assist mankind by advancing the study of predictive phenomenon in order to optimize value, reduce risk and liability, save lives and resources, and adapt no matter what the adversity is. So Cygnus X-2 is a low-mass X-ray binary. Similar to Cygnus X-3 in that it's a binary system where there is some exchange of material happening between the two stars. Cygnus X-2 is believed to be a white dwarf with a black hole orbiting it, or something on these lines. In any case, the two massive the two low-mass radio sources, I think they think it's a neutron star, but anyway, here are the X-ray transients from Cygnus X-2. If you want to watch those yourself, you can do it at the Neil Gorell Swift Bat X-ray Observatory. And we're talking about something that happened here in 2016. You really can't see it on the graph here, as it was a transient event. Again, if you want to monitor transients, you can monitor them at the Neil Gorell's Swift Observatory. And there are about around 1,200 objects being monitored. Where is Cygnus X-2? Well, here's Cygnus X-2. Way out in the Cygnus arm. I think that's Deneb over there, actually. And there's Cygnus X-2, and you can kind of see that it's a binary. It looks like a keyhole sort of a shape there. Some thermonuclear X-ray bursts were detected back in 2016. So, recent article just came out about this regarding the low-mass X-ray binary. And this particular one, discovered in 1965, believed to be a neutron star. Let me just check the life of the stream here, and we are looking good. Believed to be a neutron star with a periodicity of 9.84 days. So that's a very, very fast speed for a star to be orbiting another star. Obviously, it allows for some extreme tidal forces, to say the least. The neutron star believed to be 1.71 solar masses, while the mass of its companion, an evolved late-type star, probably what's called a white dwarf, estimated to be between 0.4 and 0.7 solar masses. So this is similar to X-3 in that it has one more massive object siphoning material off of the other one. And studying the oscillations of these things is important to cosmology. And back in 2016, there were some significant peaks in the X-ray emissions detected. Essentially, stellar flares coming out of the system. So, it can be characterized as being in the early FB, flaring branch with a puffed up accretion disk and a clumpy coronal structure while undergoing medium to high levels of accretion. And of course, that's a questionable term. If you want to read the article about Cygnus X-2, it's on phys.org's Astronomy and Space section. In another twist about Oumuamua, and this article is from The Mind Unleashed, Oumuamua leading explanation for interstellar object is, once again, back to aliens. Why is it so shiny? Why is it so elongate? How come we don't see any jets coming out of it? How is it moving so fast? How is it accelerating the way it does? And how is it even taking the vector that it has through the solar system? It doesn't make a lot of sense. And there are a lot of conflicting theories about Oumuamua, the latest of which is, must be aliens once again. So could be maybe not an occupied vessel, maybe it's a alien observatory or a light sail propelled spaceship. Who knows? Oumuamua back in the news today. The oddly elongate, and of course that's an artist's rendition, as this thing looks very strangely when you look at it, because it's rotating and it's just a weird object. It's got a cigar shape to it, and please leave a comment if you think it's a spaceship. Let's talk about another accretion disk situation. Another article here about rapid disk formation. So apparently when one massive radio source sucks material off of another massive radio source in a what's called a tidal disruption event, or TDE, apparently a massive accretion disk gets created, and it gets created very quickly. And this does produce various emissions, and those emission spectra are refracted as a result of the plasma, things like the Faraday effect. As the light passes through the accretion disk, it creates various Doppler effects as well. So another interesting system here if you want to read all about it. Another phys.org astronomy section, and here's a small portion of the animation. And this disk forms around the higher mass object, and it messes with the X-ray emissions and so on. And it forms rapidly. So that's some interesting information for you there. Let's play that. This little animation here of what that looks like. Now this is an artist's rendition also, but this is created using the data. And you've got to take long period radio astronomy typically to get this sort of data. And multiple wavelength emission spectra must be studied as well. And here's a diagram of what's going on there. And you can see the poloidal fields. A lot of this is determined by perspective. So when you view these objects down their poloidal field jets, they look much brighter and very differently than when viewing them from an angle. New observations of black hole devouring a star reveal rapid disk formation. Now, I'm not convinced that that destroys the star, as I believe that if you put the sun in a vacuum and sucked all the plasma off of its surface, the sun would be black, as dark as soot. Now, we are streaming live to Twitch. It's twitch.tv/smAsho. Thanks everybody over there who views, leaves comments, etc. And if you're viewing the videos live, leave us a comment. And we do indeed respond to them during the live videos. Today's Smashlights will be separate if it exists at all. If you enjoy the content on YouTube, please press like and subscribe on YouTube. If you're viewing on BitChute, leave us a comment. Share with your friends, share with your foes, share with your science noobs and your science pros. If you need to drop us a line, hit us up at the smAsho VoIP line. We've created it just for viewers like you. It's country code +1, area code 610-936-9799. You can call, send a text. You can even send us photos if you want something viewed. If you haven't checked out smAshomash.org, you can link to all of our stores here, as well as our affiliate. The affiliate link contains a whole bunch of products I'll just let it scroll here and explain a couple of them. And these are all Amazon affiliate links. If you're viewing on Brave Browser, for example, make sure you have shields turned off, as these are advertisements. So we've got a pulse oximeter, we've got L-lysine, MSM, and we're creating one convenient link library for you here. It's smAsho.com/affiliate. Also a couple different versions of calcium supplements, some Betty Crocker smashed potatoes, the elastomeric mask that I wear, the Honeywell 5500 series, cartridges, end caps, goggles, other PPE such as hazmat suits, chemical resistant gloves, which are great for pulling poison ivy, by the way, Nitrile gloves, my bio bug out bag, a USB keychain drive, which I have on my keychain right now, the Garnier Fructis conditioner that makes me smell so good that Joe Biden would love to sniff my hair from behind, my UV wand, here you have that. Don't forget to, sterilize yourself because it's so scary and spooky. Some Trident xylitol gum, the keyboard that I type with our viewers on, some shark socks, more supplements, bike lights, and even more supplements. Now today I'm wearing the I've survived a global pandemic so far shirt. So here you can see that. Congratulations on surviving a global pandemic so far. Your ancestors probably survived much worse. If you want to pick up that shirt, it's all linked at smashomash.org. We've also got the Biden-Harris campaign shirt. If you want to pick up one of those, again, it's all linked at smashomash.org, which will redirect you to smashomash.com. Again, congratulations on surviving a global pandemic so far. Let's get back to space. Relativistic electrons are back to very low levels, having seen a big spike and then a big crash. So here you can see once again the GOES electron flux quite low over the past 3 days. Let's check the forecast. And we're expecting a slight uptick here in electron flux. I would agree with that forecast this time. Let's take a look at the total air column. This is a visualization of the entire air column from the thermosphere all the way down to where you'd be standing on the ground with your GPS. And we see a very anomalous ionosphere, but the electron content looks fairly normal here. And here's the ionosphere. It's extremely wobbly and very anomalous. You'll see some odd-looking data here. And for all of you who consider earthquake forecasting via ionospheric anomalies, today we're seeing ionospheric anomalies. I have no idea how that correlates to earthquakes, nor am I suggesting that I do. But we see extreme anomalies here. We see a charged up ionosphere on the nighttime side. We see discharged ionosphere on the daytime side. It's just anomalous. The fact that it's more charged up in the northern hemisphere than the southern hemisphere is not anomalous, though, as it is summer in the northern hemisphere. Still, here's where stuff is in the solar system, if you were wondering. It's a great chart that I like to have on screen, and it tells folks where things like planets or Makemake is located, or perhaps Eris. Anyway, there's where things will be in a week, as Mercury swings around to make another lap. I like to use in-the-sky.org for my star charts. Create your own by putting in your zip code or whatever. It'll tell you what's going on above your head. If you get up before dawn, you may see my favorite planet, Venus, at magnitude -4.2, the third brightest object in the sky. And we see a series of quakes here along the west coast of the U.S. and northern Mexico. Nothing over a 6 magnitude quake over the past 24. In fact, it's a bit of a lull in earthquakes. Let's scroll up the list. A deep quake in the Dominican Republic. It's only a 3.1 magnitude, but it's over 130 kilometers depth. A deep quake in Indonesia, followed in short period of time, only about 15 minutes later, by a deep quake at Tajikistan. So significantly different portions of the world there, one right on the equator and one significantly farther north. And then only 4 minutes after that, a deep quake at Japan. So series of 3 quakes in a row. 3 deep quakes in a row, all across the planet. Another deep quake in Afghanistan, so a bit of a deep quake swarm there. Another deep quake at Argentina, so it's a bit of a deep quake event here, folks. 5.0 magnitude at Papua New Guinea, nearly 100 kilometers depth. And last but not least, a Redwood Valley quake. And this one is 400 meters above sea level, and there's a location of that. Located in the Laughlin Range. So we see this lull in earthquakes here, and I wouldn't lull about it. It's pretty serious. And if you're located in these regions, please have an earthquake plan. Plan to be an asset, not a liability. If you can't afford a bug-out bag, at least know which buildings may collapse when you try to evacuate yours. So these areas, I would be prepared, as we really have been seeing a lull in earthquakes here. I mean, a very low number of major earthquakes. Those areas are the places to watch. Let's move on to volcanoes. And we see a lull in volcanic activity also. Sangay is currently exploding. It's producing a 22,000-foot plume of ash. Revenador also exploding. 15,000-foot ash plume there. And Sabancaya is the third of only 3 on the list. It's exploding. It's producing a flight level 260, a 26,000-foot plume of ash. Please don't hang glide over the caldera. We see some power outages here in Louisiana and Texas. No surprise, as the hurricane is moving right up the border, making for bad times, inundation, and hopefully everybody has evacuated. We're going to talk about weather and climate in a minute. First, let's talk about this amazing thing. It's the cover story on The Mind Unleashed. Japanese farmers grow plant-specific strains of rice. They plant specific strains of rice to grow colorfully illustrated fields. Check it out. That is amazing. Oh, man. Makes you want to take a helicopter flight, as you'd have to be up in a tall building to even see this. It probably wouldn't even be visible from the ground. Check it out. That is just amazing. Ah, yeah. So, okay, let's talk about climate. How cold was the last ice age? Well, it was very cold. In the Arctic regions, it was like 14 degrees Celsius cooler than it is now. And we've got some problems here about this, as there are some, let's just say, conflicting data, as they're starting to throw carbon dioxide into the mix. So historic information about what the last ice age was like is important. But the idea that carbon dioxide had anything to do with it is just ridiculous. And here's why. How come it got so warm during the Minoan warm period, as carbon dioxide levels were nothing like what they are now? How come it got so warm during the Roman warm period? Were those Romans driving SUVs? Geez, I'm not sure. Here's the little blip that's the, quote, modern warm period, end quote. And I would also note the way civilizations collapse during these cold events. So, for instance, the Vikings settled in Newfoundland during the medieval warm period, but they weren't there by the time the last report came in from Greenland. So, the point is, folks, if we had a planet a couple degrees Celsius warmer, life would be easier, because we'd be able to farm in places like northern Canada and Siberia, which are massively fertile areas. Does CO2 correlate with temperature history? Well, it certainly does not. Here's an article from What's Up With That. Does CO2 correlate with temperature history? I look at multiple time scales in the context of the Chacun et al. Paper. So it's a pretty extensive paper here. I don't want to get too deep into it, as it's the Daily Space Weather, not a climate video. More stuff about climate can be found at, for instance, Tony Heller's Twitter feed, perhaps Tony Heller's YouTube page. Congrats to Tony Heller on having tens of thousands of subs. I remember when I first started watching his channel, he had like 8,000 subs, and now he has like 80,000, I think. Well done, Tony. Anyway, here is the graph that took my mom about 5 seconds to understand. She looked at this and she said, "Oh my God, carbon dioxide and temperature mustn't correlate in terms of the Earth's climate." I mean, there you go. If you think carbon dioxide and temperature correlate, by the way, the carbon dioxide is the black line and the average global temperature is the blue line. If you think they correlate, I don't know what to tell you. Take a statistics class or something. Go read online about how to analyze statistics. Laura has made landfall as a Category 4 hurricane, causing untold destruction. Hopefully everybody's evacuated those areas, as the storm surge was forecasted to be over 10 feet. Here are some scenes. And there's the storm track. Widespread power outages and other water-based damage. Here's a weather.gov map, and you can see quite a mess about to kick off. And you're going to have a double whammy here, as you've got rain falling right in the Mississippi, which is going to come right back down. You're going to have a cycle of water, hydrologic issues. Windy.com isn't allowed to know my location. We're not going to show you pressure maps today. We're just going to show you the last, let's put up the last 6 hours actually. See if that loads. And here's the last 6 hours of Hurricane Laura's progression. We're expecting this to track up and to the east, up and to the east. Give me back control of my computer, Wendy. There we go. And next, looking at lightningmaps.org to see if we see any lightning striking. And there's quite a bit in the U.S. right now. Some near Toronto as well. Oh, and we see some near Scranton, Pennsylvania. Next time you hear thunder, convince your foes that you're Thor by forecasting it. Quite a lot of lightning in the Western Hemisphere right now. Let's look at water vapor maps. Here is Europe and Africa. Here's one for the Far East and Oceania. Is my memory shot today or what? What's going on? Here's a water vapor map for the Americas. And you can see that Borg sphere flying over the North Pole once again, scaring and spooking people. Please give Mr. MBB333 and Gina Maria Colvin Hill a call. Let them know about this Borg sphere. I'm sure they'll want to cover it on their highly informative, fascinating YouTube channels. And here's a U.S. Doppler radar map. It looks like I'm going to get rained on. It's a good thing I cut most of the grass yesterday. And for those of you who think I'm some sort of a lawn care deadbeat, you can shove it. Next, looking at the cloud layer here, it's still dark, which is why we're using the shortwave, the NASA GOES Interactive Weather Satellite shortwave radiation satellite. And there you can see a significantly defined eye wall still rolling over land. So this got much more defined between yesterday's daily space weather video and today. And there are some forecasted tornadoes coming out of the outer arms of this thing also, I think. So if you're anywhere near this thing, make sure you have your weather up to date. Know where it's going to go before it gets there. So looking at the winds here, I mean, we're showing 92 mile-per-hour winds on the surface. As far as the flight level 250, 25,000 feet of altitude, we do not see any sort of a clockwise rotation there. And at 70,000 feet of altitude, there's not even a bump. So that's probably a good thing. Here are the jet streams. There is the western world. Here is the eastern world. We've got a couple more things to cover. I'm going to show you a close-up of the water vapor map. And that Borg sphere. Oh, it must be a Borg cube flying over North America. Check it out. You can see it right there. Oh my God. Let's zoom in on Hurricane Laura. quite a lot of moisture in the air. Not a lot of a silver lining to this one either, really. We do have some dry air here. That's a bit of a help. And you can see this dry air to its north, which is going to cause it to kind of make this rather sharp turn to the east. It has to do with the jet stream, folks. Anyway, there's a great view of that. Let's zoom in. By the way, we are broadcasting from the smAsho bunker today. If you hear that rumbling sound in the background, we're not in the Starship Enterprise or anything like that. We're just in the smAsho bunker, and its location is classified. Please consider supporting us via the links below the video, as we're tanking over here, not only in terms of YouTube subscribers, but in terms of finance. So consider becoming a Subscribe Star or perhaps a Patreon, which, by the way, is the true source of funding for the content. Thanks to our patrons for being assistant and associate producers of the content. Thanks to the smAsh team for sharing the content on your social media, etc. We greatly appreciate that. Please leave a comment, etc. Tell your friends and foes. Tell your science noobs and science pros. Visit the links at smashamash.com, or if you prefer smashamash.org, it's going to just relocate you to the same site. Thanks for flying American Smashways. Allow me to vanish and remind you to please keep your head and arms inside the smash plane at all times, as we've got a bonus of features. We're going to show you the 131 angstroms view of the local yellow dwarf, the 48-hour SDO video, that is. And here's a blurry colorized magnetogram. We could see a sunspot forming down here. This could be a thing, but it doesn't look yet like a sunspot. Another region to keep an eye on besides that north portion is that one. And when I say ion, well, the pun is intentional. Again, no umbre. And we've got a partial eclipse of the SDO causing this blur. No umbre associated with this active region either. And you can't even see any lightning there, actually. And here's the 131 angstroms view. This is one of the scopes that takes 10 images per minute instead of only 2. Let me check the stream in the chat. Thanks again, everybody, for tuning in. Remember, stare at the sun, don't drink, and if you do, don't drive. And since it'll never be now again, may that solar wind be at your back, and that covidiously absent from your locality, county, state, nation, hemisphere, planet, solar system, galaxy, universe, and multiverse. Can we be friends even though you're made in Ched? Ched? Aw, COVID. Poor COVID.